and in inverting terminal we provide 7 microvolt of DC. So how are you going to solve this problem? So V out is A times V in 1 minus V in 2, and A is 2 into 10 to the power 5, V in 1 is 5 microvolts, and V in 2 is minus 7 microvolts. This is DC, right? We are first providing only DC sources. So the answer would be 24 volt DC, right? But as you can see, the swing, what was the maximum swing possible? Plus minus 14 volts, right? So the output will be plus 14 volt. Right? Secondly, the output for the AC sources, we have provided 10 millivolt, or we have applied 10 millivolt at terminal 1 or at non-inverting terminal, and 20 millivolt RMS, right? Peak to peak would be, sorry, peak would be root 2 times VRMS, right? 2 into 10 to the power 5, 10 millivolt RMS minus 20 millivolt RMS. So the output will be minus 22,000 volt RMS, which is not possible, right? Again, क्योंकि हमारा what was our voltage swing? The voltage swing, maximum voltage swing is plus minus 14 volts. So your V in 1 was this 10 millivolt. If you watch the video I posted there, I think I have used the software, right? So that you can also make an account and you can see all of these things. So this is your V in 1, this is your V in 2. And this maximum value would be root 2 times 10 millivolt, root 2 times 20 millivolts. And the output you will see, you will get square waves of type this. माइनस से स्टार्ट होगा कि प्लस से? Because you will subtract this V in 1 minus V in 2, right? So ऐसे हो जाएगा, right? So and the output, if you see, A times V in 1 minus V in 2, right? A times V in 1 minus V in 2 is your output given. It should not exceed plus minus 14 volt. Correct? So we'll see that it is exceeding. If you just subtract V in 1 with V in 2, the subtraction would yield this type of signal. Correct? And then you multiply with A, right? A large gain, a very large gain. So we'll see that this signal will be clipped off and the output would look like a square wave, right? Of plus minus 14 volts. So this is the output. This I asked you to solve because for very minor value of V in 1 minus V in 2, for very small value of V in 1 minus V in 2, the output will go outside this range, right? Because 2 into 10 to the power 5 is the the gain, right? The gain is very high. So next, let's see inverting amplifier. We have seen differential amplifier here, right? So here we have applied input to both of the terminals. Inverting, yani we have to apply input voltage here, right? This voltage either can be DC or can be AC, right? So it is not for biasing, it's your input signal. Because DC is nothing but a zero frequency AC, right? So it can be a signal. And I told you that amplifier can amplify DC also because we are not providing any capacitor in between. Correct? Anyways. This terminal you will ground, right? Because we want to use this as an inverting amplifier. Correct? And then what would be the output here, right? This is the load resistor. And you want to see the output here, V out. So, and this, you can also have this some source resistance. So let's try to understand this with this example. Determine the output voltage for inverting amplifier. Correct? This is your inverting amplifier. When your Vin is 20 millivolt DC, and for the second case, your Vin is minus 50 microvolt DC, or you can assume it's a 30. And the parameters are similar to our previous example. So A was 2 to the power 5 open loop gain or the voltage gain. So V out would be A times V in 1 minus V into. This is your V in 1, right? This is your V into. V in 1 is 0. V in 2 is V in. V out is minus a V in. That is why we are calling it as a inverting amplifier. It is giving you a gain of A as well as it is reversing the polarity of your input signal. That is why we are calling it as an inverting amplifier, right? Similarly, you can see if you apply 30 millivolt of DC, 2 into 10 to the power 5 and 30, क्या होगा? You will get minus 4,000, minus 8,000, right? Minus 6,000. But voltage swing is plus minus 14 volt because saturation is almost the amplification property of your op amp is something like this. This is your VID, this is your V out, and this is your saturation, plus saturation and minus saturation. Saturation is little bit lower than VCC, and this is little bit lower than VEE. So if you are applying plus minus 50, we are assuming that we are having a saturation of at plus minus 14. So the answer would be minus 14, right? Because it is higher than 6,000, correct? It will be clipped. Similarly, your V out for the DC, this is your 50 microvolt AC लिखना है, AC. And this is a peak. So what would be the answer for this? Minus 2 into 10 to the power 5 because minus a V in is already negative here into minus 50 microvolt. So the peak value of this will be 10 volt. Right? So if what can you observe here? If your signal is very, very small, microvolt range, then you get amplification. Right? It will not be clipped off. Got 10 volt peak comes under the plus minus 14, right? Plus 14. This is the 10 volt means how what type of sinusoidal signal you will get? This type, right? 10 volt. And the input was in microvolts. Why I am plotting it is like this? Because it is written minus, right? Minus 50. So it is minus 50 microvolt peak value. Then our amplifier, the op amp is giving a gain characteristic, you can exploit the gain characteristic, otherwise it will go to saturation, right? Clip हो जाएगा. Similarly, you can see the non-inverting mode, non-inverting amplifier. कैसे होगा? You have to apply the source at positive and you have to ground the negative terminal and you have to measure the output here, right? Across the load. Correct? A will be, not A, the output V naught will be A times V. As you can observe, there is no positive or there is no negative sign because there is no polarity change, right? The polarity of output is same as the polarity of your input signal. What we have observed from these two examples, that our op-amp reached saturation for even for very small values of input signals, right? Millivolt में तब तो जाएगा ही, microvolts में थी, then it was okay. And what was the reason of that? The reason was high amplification gain. It was of the order 2 into 10 to the power 5. Because of this, you have seen that your output will go outside the saturation range. And you will see that this gain is also a function of frequency, temperature, and power supply. Frequency ka we have discussed a few points, right? Gain bandwidth product. Okay. So we have discussed in the last class that gain bandwidth product is constant, right? If your amplification is too high, the bandwidth over which, first of all, let us see what is bandwidth in the context of op-amp. Bandwidth is band of frequency over which gain is constant. And practically, if I ask you to plot see the bandwidth, how would you do that? You will start with the sinusoidal signal of a small frequency, you will increase this frequency, right? And for every frequency, you will see the output V out, correct? V out divided by V in is your gain. So you will plot it and you will see if this is the frequency versus gain, right? It might be in dB. For this frequency range, the gain is almost constant, so the bandwidth of this amplifier is this. Correct? 3 dB, you can also define a 3 dB bandwidth, right? So there are various ways you can define bandwidth. 3 dB bandwidth, almost constant बोला ना? इसको लिख दो almost constant. Then you can also define 3 dB bandwidth. Maximum go down, 3 dB down from the maximum, and this will give you the bandwidth. So we have seen that practically it is very, and for 741, what is the practical bandwidth? 5 Hz only. If your signal is outside this range, outside 5 Hz, you cannot amplify it. Correct? So these are the limitations which motivates us to do something extra, to do something intelligent. First, what was the drawback of this open loop configuration? This is an open loop configuration. Why we are calling it open loop? Because there is no feedback, right? So this is an open loop configuration. And there are few drawbacks of that. What are the drawbacks? The bandwidth or the frequency range is very small. And second, very small value signal can be amplified, right? So we have to do something. We have to do something special, and that is called feedback, right? So by doing feedback, we will sacrifice some gain, right? But it will be practical. There is no point of having this type of amplifier. Okay, its gain is very high, but it's not practically useful for us, because you cannot amplify a signal more than 5 hertz. You cannot simply amplify a signal whose value is more than 5 microvolt or 10 microvolt. If it goes to millivolts, you cannot amplify it, right? Because it will be distorted, it will be clipped off. So amplification, you will not get the amplification. So there is no use of having such an ideal. बोलते हैं ना ideal है but practical नहीं है, right? So in order to make this a bit useful in practical life or day-to-day life, what we do, we apply feedback. By applying feedback, we lose in terms of gain, but we win in terms of practicality, right? So there are three types of feedbacks, right? Negative feedback and positive feedback. This is the next chapter of your book, Op-amp with negative feedback, chapter 4, I guess, right? Chapter 4. So, what is the positive feedback and what is negative feedback? Positive feedback means your signal which you are providing feedback, you are providing feedback from the output, right? That must be in same phase with the input signal. So same phase input. Or you can also remember like this: whenever you provide positive feedback, the effective input which goes to that device will be higher. The effective, because this is your V in, then you provide some feedback, the effective goes V in plus some feedback, right? What I'm saying, the effective input, effective will be V in without feedback plus some feedback. Whenever this V in is, if your VF is in same phase, it will add up the effective signal, correct? If it is out of phase, it will decrease the effective signal, right? 180 phase का क्या मतलब? You are providing A sin omega t and you are having minus A1 sin, some, right, out of phase. So effective will be A minus A1, correct? So this is decreasing the effective voltage which is going to the device. क्योंकि तुम feedback, we provide feedback, right, and we give error signal generally, right? You can think it like that. So negative feedback, the feedback signal is in 180-degree phase, out of phase, 180-degree out of phase, right? Or odd multiple of 180. क्योंकि अगर even multiple हो गया, if it is even multiple of 180, it will become same phase, right? So what we have seen? We have seen that we can use our op-amp in 3 types of configuration. Differential, depending upon the way we are feeding the input. If you are feeding the input at both of the terminals, it is called differential amplifier. If you are feeding the input signal at only the inverting terminal, it is called inverting amplifier. Otherwise, it is non-inverting amplifier. And according to application, we choose these type of configurations. If you want to invert the signal as well as amplify, we would choose simply inverting amplifier, right? If you don't want to invert, we just want an amplification, we would use non-inverting amplifier. So we have seen if we use these 3 configuration along with the open loop type of arrangement, we have seen that there will be few drawbacks. Drawbacks is a very small signal goes to clip, it clips, right? Go to saturation. So we cannot amplify very small signals, and also we have seen the bandwidth is quite small. So it is impractical in a way. So what we do, we do feedbacking. By doing feedback, we lose in terms of gain, but we win in terms of practicality, or you can say now it is useful for you, right? It was ideal, but it was not useful. So I would say that by doing feedback, it becomes useful. Let's see that we have seen that broadly we can classify feedbacking in two ways: positive and negative. By positive, it means the effective input that goes will be higher than the input which was before the feedback, right? And negative feedback, the effective input that goes into your device will be lesser than the input which we are providing without feedback. So in that way, you can remember, or the classical definition is in phase and out of phase, right? So we have seen this. Let's see how can we. You have a two-port device like this, or op amp. How can we do the feedbacks? The ways we can do feedback is also called feedback configurations. So first is voltage series. I hope you might have heard it, but let's repeat it. So this is your feedback configuration, that is voltage series. This is your input. Correct? This is your feedback. This is your op amp. This is your feedback circuit. And what you have to do, you have to provide a voltage series feedback. So first you have to extract the voltage. Correct. Then this you have to provide in series with the previous the input voltage which you are providing feeding without the uh, without feedback, right? So this is called voltage series. Then दूसरा क्या होता है? What is the second type of feedback configuration? Voltage shunt, current series, and current shunt. So quickly I would just draw. This is your op amp. Now you are having voltage shunt. So first extract the voltage. You have extracted the voltage. Now you have to shunt it with the already provided. So this is the feedback circuit. So this is your VF, right? Feedback voltage. This is the feedback voltage, right? Which you get from the feedback circuit. This you have to, ये तो सीरीज हो गया, अब शंट करना है. So the way we do it, right? This goes to in parallel with the previous one, right? This is your feedback circuit. Voltage series, voltage shunt, then current series and current shunt. And so you need to pass the whole current to feedback circuit. This is your feedback circuit, and this is our op amp. Current series, current series. So the VF value of VF is in series with the output, with the input, sorry. Current series and current shunt. So we need to extract the whole current. This is your feedback circuit. The whole current goes inside the feedback circuit. And now you have to shunt the VF. Shunt means in parallel. Correct? So current, shunt. Current, series. So this is the 4 configurations which are possible. And these are all the feedback arrangements, right? So let's study voltage series configuration. कैसे करेंगे? How would you do that? This was your op amp. These are the general configuration, right? You can also use a 2-port device, any 2-port device. But our op amp is something like this. ठीक है. Voltage series. This is our source. Correct? Or you can also see in few books, these 3 points are connected with ground. So this is the output, right? So output voltage you are feeding in series with this, correct? Because this is your VID, which will become Vs minus Vf. VID is Vs minus Vf, correct? So as you can see, this is a negative type feedback, right? Negative feedback. That is why we are providing the feedback to the negative terminal so that the effective input will be less than Vs, right? If it was ground, right? If it was ground, you will have Vs only, right? Now we are having Vs minus Vf. It's a negative feedback. We deliberately are providing negative feedback, right? Because we are connecting this to negative terminal. Do it vice versa, you will see something else, right? But that is not our aim. Not vice versa. You have to provide some feedback here and you have to add. You will see it when we discuss positive feedback. Here we are discussing negative feedback. So VID is Vs minus Vf. What is your feedback circuit here effectively? This is your feedback circuit. Here you can write this line, feedback signal always oppose the input signal. This is a very good definition of negative feedback, that the feedback signal always oppose the input signal. Okay? This signal. So this is your V1, this is your V2 feedback circuit. I told you that once we do feedback, we will lose in terms of gain. So you will have some new gain, right? So the gain is what? Output divided by input Vs, right? Because originally it was Vs. This is just the feedback, right? This is your definition of feedback gain, right? So when we use voltage series configuration, what is the AF? This you have studied, I think. This is non-inverting mode, no? Effectively, if you redraw it, you might have done this. Sorry for my drawing. Drawing is not. Just look at this. Huh? And this. Same है ना? And this you have studied. Lab में किया होगा. You might have done this. So what was the AF? Correct? Let's try to derive it. Even if you know, let's try to do it again. So we need to discuss four quantities mainly. Closed loop gain. It is called closed loop gain. Closed loop voltage gain. Closed loop voltage gain. Input resistance and output resistance. And bandwidth. You will see that if you provide feedback, all of them will change. Earlier input resistance was something else. The new input resistance with feedback will be different, right? It is not like that, okay, we are making it practical, so nothing, no other parameters would change. The parameters would have definitely change, right? This we have to see. So let's try to derive. And by definition, AF is V naught by Vs. Okay, so what is your V naught? It is A times V1 minus V2, where A is your open loop gain. Correct? See, this is nothing but this. Whatever VID you will get, it will amplify it, A VID, and this is your R naught, right? Do you agree? Inside, if you see equivalent, I draw equivalent circuit, right? पीछे पे in the last class, I think. In last class कहीं पर किया था मैंने. Yeah. So what would happen inside that black box? Whatever VID you get here, you will amplify it. Correct? उसको नहीं पता है. It does not know कि from where this VID is coming. Is it coming from two voltage, different voltage sources, or it is coming from a feedback and voltage source, right? This would be output for this device. For this device, this is the output. A times V1 minus I2. And what is your V1? See here. V1 is Vs. V2 is Vf. So what is your Vf? Vf here, you can see that these RL and RF and R1 are parallel. Voltage across RL is V naught, right? Voltage across these two resistors which are in series will be Why it is in series? Because this is very high and the current which is flowing through it will be really small, right? That you know. Ri is very high, right? So what would be Vf here? R1 divided by R1 plus Rf multiplied with V0. All of you agreed with that? Dekho, please look at this. Correct? If we put this value here, you might have derived it using the concept of virtual ground. We will discuss it later. Is this right? This is Vs and this is V0, which is equal to V0. After solving this, यहीं पे कर देता हूँ. This is where I would put the answer. V0 is V0. Okay, just simplify it. क्या होगा बताओ? AVS is equal to V0 AR1 divided by R1 plus RF plus 1. So V0, this is your VS divided by A. AR1 plus R1 plus RF divided by R1 plus RF. So next would be V0 by VS, right? This was our target. A times R1 plus RF AR1 plus R1 plus, right? This is your AF. Do you agree? That this is your AF. Closed loop gain. This is your closed loop gain or gain with feedback. Open loop tha na, so that is why we just call it closed loop. Closed loop gain. This not different, right? We have studied 1 plus RF by R1. Correct? What's the difference, RF? From where you are getting this? If you remind, I mean, A is very large, right? AR1 plus R1 plus RF would be approximately equal to AR1. Correct? Because A is into the power 2 to the power 5 and R1, R2 to R1 are small, right? We don't take values of R1 and R1 very large. One plus feedback resistor divided by the input resistance, input resistor. This we have studied many times. One of the best thing of having this closed loop gain is that you can control the closed loop gain. Open loop gain was not in your control, but you can change the value of gain according to your requirement by appropriately choosing the values of RF and R1. So if you want a gain of 10 or 11, how would you do that? What are the possible choices? For AF equal to 11, if you choose it as a 1K, you can choose it as a 10K. Correct? Accordingly, you can have various choices. So I would say the best thing is that you have control over AF. Correct? Now the value of closed loop gain is not in the order of 2 to the power 5, 10 to the power 5, right? It was 10 to the power 5 for 741C, right? That was causing trouble that we cannot amplify very small value signals. But now you can, because our gain is 10, 12, 20, whatever we want. If you want a 10 times bigger source, 10 times bigger signal or 10 times larger signal, we can do that by selecting the value of R1, RF and R. Correct? But now the question is, can we choose the signal of any frequency? Because for the open loop, the frequency should be very small, right? So that you can see from the gain bandwidth product. For open loop gain A, bandwidth for open loop is B by W0. But now with feedback or for closed loop, the bandwidth would be this. Am I right? And AF is देखो अभी निकाला ना 1 plus AF is 1 plus RF by R. So it's difficult to see from this whether it is increasing or decreasing, right? नहीं समझ में आ रहा, right? A times BW0 and AF was देखो BW0 was very small, right? But A was large. Correct? 5 hertz, 2 into 10 to the power 5. You choose this as 11. 2 into 10 to the power 5 into 5 hertz divided by 11. Now you can operate over the frequency range of 10 to the power 4. Or you can say 10 to the power 10. 5 to 10. 10, 10 goes 10 and 11 are almost equal. So you can operate if your input frequency is even in megahertz or kilohertz range. Correct? Now the question is, what is your new input resistance? See, this was your device, right? हो गया कुछ लोग, anyways टाइम हो गया शायद. So we'll see input resistance and output resistance. Hopefully I have to put a video because the course is going slow. So input resistance and output resistance along with one numerical, I would put that, right?